All right, good evening everyone. My name's Kalia Primer and I'm a current PhD student here at the University of Adelaide and I'm also your MC for tonight. Before we get started with the competition, I would like to welcome Uncle Rod onto the stage to do a welcome to country. Hang on, there we go. Please welcome Uncle Rod.
Bit wobbly today. Port Adelaide lost on the weekend. Being a Port Adelaide boy, I'm a bit in mourning still, but anyway, we'll get over that. It's my pleasure to give the welcome. I do so on behalf of the Kaurna Elders. So I'm a Kaurna Elder. I'm Cultural Advisor at Wilta, which is the Aboriginal Education Unit at the uni. And anyway, I just wanted to say that I'll keep to the 3-minute limit. But language is a passion of mine, and I think I believe that if you're in Rome, you do as a Roman. So if you're in Kaurna country, Adelaide Plains, you should do as the Kaurna and speak our language. That's our dream anyway, to teach our language to all the schools on the Adelaide Plains. We hope to achieve that in the next 10 years. So that's just an ambition. But our language, our old people said, if you know our language, you'll be better connected to our country. If you care for our country, the country will care for you. So there's just little things, but they're important things to know about our culture, because our people were educators and they had conferences in our country for over thousands of years, and we believe that no one person had the monopoly on knowledge, or one nation, one group of people. So we invited people to come and share their knowledge with us, so that we all can learn together and learn off each other and be better connected and get along better, and we don't have to have wars. So, because our people didn't have wars for over 10,000 years, we protected each other's country and we respected each other's country. So there's little things about our culture. But I'll get on with the welcome now. I'll stick to the 3 minutes. Machawanga Gana Mena, Nai Wangani Mani Nabudni, Gani Atana, Naberko Makalankla, Tandanya Mena Aku, Nachi Yungandaya, Nachi Yakandaya, Padni Adu Wadu. So on behalf of the Kaurna people, I welcome you to the Kaurna country. I do this ambassador of the Adelaide Plains people. My brothers, my sisters, let's walk together in harmony. Natalia, thank you and have a good night.
Thank you very much, Uncle Rod. So I'm absolutely delighted to welcome you all tonight to the University of Adelaide finals of our 3-minute thesis competition. And we're holding that both here in the Braggs Lecture Theatre and also online. So the 3-minute thesis is a national competition. It was developed by the University of Queensland back in 2008, and since then the idea and the concept has been adopted by over 600 universities across more than 59 countries. It's also become a really important event in the Research Tuesdays series, because we love any opportunity that we can take to showcase the work of our fantastic early career researchers. This event also provides a fantastic opportunity for our PhD students to hone their communication skills and really get some real-world practice communicating their research to the general public. So over the past few months, dozens of research students across the university within each faculty have been vying for a place at these finals, and tonight we're going to hear from 10 of the best, so 2 from each faculty. This year, however, we have had to adapt the format a little bit in order to manage the changing situations that we're dealing with, and so we've created a hybrid of both the online and in-person elements. So this has meant that all of the 3-minute thesis heats and the faculty events have been conducted via a video submission rather than an in-person presentation, and that's also what our judges have used to make their final decision about the overall winner. But tonight we will have the opportunity to see each of our finalists present live, and then we all get to vote in the final 2 categories, which is the People's Choice and the Student's Choice. So although the setup is a little bit different this year, I do know exactly how all of you are feeling. Maybe I was a little bit less nervous, I didn't have to present live, but I did take part in the competition last year and was lucky enough to be the overall winner last year, it was an incredible surprise. and I've been asked to sort of just say a little bit about what I've been up to since being named the winner. So I've been able to speak at the Northern Communities Health Foundation public lecture. I got to open for Dr. James Mukey, which was pretty cool. I was able to deliver a lecture as part of Research Tuesdays and also co-MC some of the program with Dr. Nigel Rogash. I went on the radio to talk about my work, and basically I've just met a whole bunch of incredible people, both within the wider community and here at uni, that I would not have met otherwise. So it has been a fantastic experience, but I'm very happy to be able to hand off the torch at this stage. So my advice to all of you guys is just try to relax, take a deep breath, but I guess overall aim to use this opportunity as a stepping stone no matter what the overall outcome is. So that's my advice. And so tonight's winner will represent the University of Adelaide at the virtual Asia Pacific Finals, and that's going to be held early next month, and that will also be via a video submission. But before we begin, I would like to invite Dr. Monica Kerr from the Adelaide Graduate Centre up here to say a few words. Please welcome Monica Kerr.
Thank you, Kalia. I'm here in my capacity as Director of Researcher Development and Career and Research Skills Development for all of our researchers, including our research students at the University of Adelaide. The Research Tuesday series of presentations is an important mechanism by which the university shares their research endeavors and impacts on society with the wider community. Normally, you would come along to one of these presentations to hear an in-depth discussion on a particular topic of interest, typically delivered by one of our more experienced researchers. Tonight is a little different, of course, and we at the University of Adelaide are excited to feature 10 of our emerging researchers who are also this year's finalists in the 3-minute thesis competition. The 3-minute thesis format will give us all the opportunity to learn about 10 different research projects spanning a range of different disciplines, presented in terms that will be comprehensible to all of us. It's interesting to reflect on why is the 3MT so successful? Because as we heard from Kalia, this competition has been around for more than 20 years and is a worldwide phenomenon. Firstly, I think because it is highly effective in communicating the important and impactful research of our research students. Their contributions are not to be underestimated, because while they are training to become independent researchers, they are also undertaking and conducting high-quality research. Research students are the backbone of Australian research, comprising more than 50% of the research workforce in Australia. And in a research-intensive university like ours, they are crucial to the success of our research programs. I'm in a fortunate position of being able to see a cross-section of the kind of work that PhD and research master students undertake, which covers a very broad set of disciplines in a comprehensive university such as ours. While tonight's presentations are only exposing a small subset of that activity, it nonetheless gives credit to the body of work being done by our research students. The second reason why the 3MT competition is so successful and important is because of the increasing importance of concise communication, which is becoming a critical skill for successful professionals, including researchers. Virtual communication has changed the way we search for and consume news. We live in a time when people are overloaded with information and don't know which sources to trust. Attention spans are low as we consume and we're used to consuming and learning in ever more compressed and time-efficient formats. We must be able to communicate complex, sometimes highly nuanced messages accurately, efficiently, and in a format that holds attention. But at the same time, the research that we are undertaking and the methods we're employing are becoming increasingly more complex as we address more difficult research questions, using increasingly sophisticated technologies and methods. So communicating what we do, how we do it, and their impacts in a single slide and 180-second presentation is a significant challenge. Anyone who can master that art has acquired a very valuable skill indeed. I know that once again, the standard of entrance in this year's competition has been very high, and that we are all in for a very enjoyable, interesting, not to mention educational series of presentations. I hope everyone who has participated in the competition this year has benefited from the experience. And I want to thank everyone, including those who are not here tonight, who has taken the considerable amount of time needed to prepare their presentations. and the staff who have handled the significant challenges presented this year. I congratulate all of the finalists for making it this far, and I wish all of you good luck this evening. Thank you.
Thank you very much, Monica. All right, so before we begin, again, I would just like to talk through the competition rules and the judging criteria so you all have some context for the decisions that have been made. So there are some, it's quite simple, but the rules are quite strict and they can be a little bit challenging to follow at times. And I'm not going to be able to see that while I talk, but I've got it here, so that's fine. So you can have a single static PowerPoint slide, no slide transitions or animations, no additional electronic media is permitted, no additional props, so no costumes, no musical instruments or lab equipment. You get 3 minutes, that one's pretty obvious, but if you do go over 3 minutes, you will be disqualified. Luckily, I don't think we had any of that this year, so that is good. Your presentation does have to be spoken words, so no poems, raps or songs, and you have to start in front of the camera. Oops, sorry about that. So the presentations are considered to have commenced when a presenter starts, either by a movement or when they start speaking, and as always, the decision of the adjudicating panel of judges is final. All right. So each presentation will be judged based on two set of criteria, or sort of two main categories, and these are firstly comprehension and content. So I'm not going to run through all of these, but just a couple of the really important ones are, firstly, did the presentation provide an understanding of the background to which the research question is being addressed and its significance? That's clearly incredibly important. And then another very important one, did the speaker avoid scientific jargon and explain terminology and provide adequate background information? As Monica said, with our projects becoming more and more complicated, that can get really tricky. Okay, so then the second category is engagement and communication, and that takes into account the following. Did it make us want to know more? And importantly, were they careful to not trivialise or generalise their research? Again, it can be really difficult to do that, but is incredibly important. Are they enthusiastic? Do they maintain our attention? Do they have good eye contact, good vocal range? And again, importantly, did the PowerPoint slide enhance the presentation, and was it clear, legible, and concise? All right, so those are that's our judging criteria. So in terms of the judging system, this year our judging panel was very hard at work prior to tonight and have been judging the video submissions for the past week using those judging criteria that I previously mentioned, and they scored each presentation completely independent from one another. The decision has been made already, and the winner will receive a $2,000 travel voucher to be used for any travel in relation to their research. So we'll find out later on at the end of the event who the panel has decided to be the overall winner. We do also have the People's Choice Award. So tonight, all of us in the audience and those of you online will be given the opportunity to vote for who your favourite was, which I think is democracy is very important, clearly. So after all those 10 finalist presentations, a live poll will come up, and people at home will be able to vote using the live poll, but we'll also have a QR code come up on the screen that everyone in the audience can use to vote for their favourite finalist. And the winner of the People's Choice Award will receive a $1,000 travel grant, so it's not bad. We also have the Students' Choice Awards. So this year we've got 14 year 10 to 12 students from the following schools who've come along: USC, Pulteney, Adelaide High School, St Peters and Eynesbury. They've been invited along this evening to view all the 10 presentations, and then they get to sort of discuss as a group and submit their choice as the winner for the Students' Choice Award. So the winner of the Students' Choice Award gets a $250 voucher, and that will be presented by a representative from the schools. So let's get started. Our first speaker, we'll start off, actually, I'll just say another couple of things. I will introduce each finalist and their presentation topic, and then they're going to hop up onto stage to present their 3-minute thesis. And then I've got one question for each finalist that has been submitted by the judges. So I'll ask them that question as they're up on stage, they'll answer, and then we'll repeat that process until we've got all 10 presentations done. And then once those are finished, that's when we'll go ahead and do the live voting for the People's Choice. All right, so now we'll get started. So we're going to start alphabetically, and our first finalist for the night is Alana Delane from the Faculty of Sciences, and her presentation title is "This is the House That Wasps Built." Go ahead, Alana.
When I talk to my kids about being a scientist, they assume I'm a chemist, mixing chemicals that bubble and explode, or that I wear a lab coat, looking down a microscope and finding cures for diseases. When I start talking about DNA and tiny wasps, I'm met with looks of confusion and mild fear. I work in an area of science called taxonomy. My PhD research focuses on discovering a group of parasitic wasps which control another group of insects called lerps, which live and feed on the leaves of eucalypts. I find the wasps and the lerps, take them back to the lab, extract their DNA and record everything I can about them. Why? Well, consider this. It is a dream of many Australians to build a home. We take for granted that there will always be a supply of timber available to do this. But as Australia's climate dries, forestry is becoming more expensive and less reliable. We rely on timber imports to sustain an industry which generates thousands of jobs, huge economic profits, and builds homes for Australians. Eucalypts are a major species being grown offshore, and lerp outbreaks are increasing with them at an alarming rate. The parasitic wasps, which can control those outbreaks, have been left behind on Australian shores, leading to the death of plantations and costing billions of dollars. My research contributes to taxonomy by discovering which wasp can be used to control these lerp outbreaks. A lack of taxonomic research into this group means that the wasps currently have no names, no records, no stored DNA. And without the formal recognition of what these species are, they might as well not exist. We need to know as much as we can about insects because the interactions between them, plants, animals, and humans are at the core of so much. Insects are the source of many pharmaceutical and medical treatments. They provide food and energy, act as waste disposals, and repair environmental damage. They're important pollinators and essential pest controllers. But our current understanding of Australia's described insect fauna is estimated at only about 30% of the actual number. This is like walking into a library and every book you pick up has a front cover, but it's filled with blank pages. You're never going to find the knowledge you seek because the information just doesn't exist yet. In the eyes of my children, the study of parasitic wasps isn't nearly as cool as curing diseases and definitely not as cool as making things explode in a lab. But one wasp species discovery at a time, it is filling the pages of those books.
Thank you very much, Alana. That was fantastic. So the judge's question for you is, what other factors went into you choosing the lerp predator to study out of all the wasps that haven't been identified?
Okay, so the group that I work on, the wasps are quite host-specific to the lerps, and the lerps are very host-specific to the eucalypt species that they use to complete their life cycle. So it's kind of a no-brainer. You pick the wasps and the lerps sort of come with them, and then they come with the group of eucalypts. So you can begin to examine these great interactions between three levels of species, which is really important.
Fantastic. Thank you very much.
Thank you.
All right, finalist number 2 is Caitlin Adams from the Faculty of Arts. Her presentation is titled "Spotting the Difference in Online Video." Take it away, Caitlin. Sorry. There we go.
I want to invite you to play a very quick game of Spot the Difference. Behind me, there are 2 screenshots. Both of them have come from YouTube videos, and both of them feature a singular young woman speaking directly to camera and filming from her bedroom. At face value, these 2 videos look functionally identical. However, there is one very key difference between the 2, and that is that one of these women is an actress, and she's playing a character in a fictional video. And this is where Spot the Difference starts to get a little bit interesting, because all of a sudden, all of you have just looked back up there to try and work out which one is which. And I want you to just pause for a moment and think about the kinds of things you're actually looking for. Are you looking at the speaker, trying to work out which one seems more authentic? Maybe you're looking for signs of production value, like the lighting or the quality of the video. Whatever you're looking for, what your brain is trying to do is identify individual pieces of information that tell you the content you're looking at. I'll put you out of your misery and tell you that the video on your left is the fictional video. My research is looking at these fictional videos. I'm calling them mimic vlogs. I'm calling them this because they actively replicate the user-generated format of a vlog, such as the video on the right. Mimic vlogs are really interesting because what they do is they're telling a story in a new way for an online audience, but in doing so, look like something else. I'm interested in how audiences perceive these videos, particularly in comparison to other things online that look like something that they're not. I'm also interested in identifying the pieces of information that audiences use to identify them. We might think of other things online that look like something that they're not. We might think of fake tweets or parody videos or mis- and disinformation and fake news. We know how important it is to be able to identify those pieces of content, and mimic vlogs are no different. I'm asking participants to watch a series of 8 videos and then try and categorize them as either fictional or real, and then tell me the pieces of information they used to decide. So far, my participants have been able to get, on average, approximately 5 out of the 8 videos correct. And interestingly, some of the videos are more susceptible to being misidentified than others. Perhaps more interestingly is the fact that the same piece of information is being used by different participants to come to different conclusions. For example, some participants have found one video too scripted, and so one participant has said that it's a real video, and the other has said that it's fictional. What this tells us is that these pieces of information can be used in different ways, and that makes the line between what's real and what's fictional kind of blurry, and that makes it really difficult to spot the difference.
Fantastic. Thank you very much, Caitlin. So your question is, quite broadly, what do you think the impact of this research will be?
Ooh, great question. I think that this research goes kind of obviously hand in hand with that stuff around fake news and information disorders, because I think that they marry together in a way that makes a lot of sense. But where I would love this to go is towards audience media literacy skills, because I think a lot of the time when we talk about fake news or things online that look like something that they're not, we think about the ways that platforms can help, or the ways that creators can make stuff that makes it more obvious. But we don't really talk a lot about the audience and what the audience needs to know. So if we can identify the things that people are looking for, then we can try and help develop those media literacy skills, which I think is really
fantastic.
important.
Thank you very much, Caitlin.
Thank you.
All right. Our next speaker is Chai-Yi Liao from the Faculty of Engineering, Computer and Mathematical Sciences with her presentation, Plastic Recycling Reimagined. Go ahead, Chai-Yi.
It's been a long day. As you're getting ready for bed, a pungent smell fills your room. It reminds you of the scent of rubber being burnt. After a few months of this, you start to realize that your neighbors are developing respiratory issues as well as rashes on their skin. This is what it's like to be living in Jinjarom, a small town located in Malaysia. Back in late 2017, the Chinese government implemented a new policy completely banning the import of non-industrialized plastic waste. Many countries found themselves scrambling to find different methods to dispose of their plastic waste. Majority of them choosing to send off their waste to other countries such as Malaysia. There, illegal plastic recycling factories were soon established. These factories completely disregarded the health and safety of local citizens. They polluted the land, the air, and the water supply. The introduction of this Chinese policy served as a huge wake-up call for many governments who found themselves unequipped to process their own plastic waste. Unfortunately, although plastic production has grown exponentially throughout the past few decades, recent studies have shown that less than 10% of global plastic waste is recycled. One of the biggest challenges behind this is because current technologies struggle to find ways to produce high-quality recycled products at a low cost. However, hydrothermal liquefaction is a process that has shown significant potential to be able to achieve this delicate balance. Hydrothermal liquefaction is a process that decomposes plastics in water under high temperatures and high pressures to produce a liquid product. My study focuses on investigating the effects of biomass presence on the hydrothermal liquefaction of plastics. This is important because hydrothermal liquefaction can produce high-quality fuel alternatives as well as recover valuable chemical compounds such as plastic monomers. All of these at a lower operating pressures and temperatures compared to current technologies. Also, recent studies have shown that the addition of biomass to plastics in hydrothermal liquefaction in fact enhances the product yields and quality. A direct opposite of current technologies where the presence of biomass negatively impacts the recycling outputs. My goal is to understand the fundamentals of how different biomass interacts with different kinds of plastics. Building on that, I will be able to determine how to optimize the process and what kind of feedstock best suits hydrothermal liquefaction. With this knowledge, I hope to be able to implement this technology on an industrial scale globally, introducing a new way of plastic recycling, and hopefully increase the rate of plastic recycling and prevent the situation in Jinjarom from happening anywhere else in the world.
Thank you, Chayi. So your question from the judges is, how would the outcomes of this research be applied at scale, industrially, around the world?
So what we're hoping is that because hydrothermal liquefaction is originally a biomass-based decomposing process, what we're hoping is that because mixed waste, the things that you go in the red bin, it's often not sorted, right? And what we're going to do is, if we understand how plastics impact the outcome of this, we'll be able to do it on the bigger scale, and it doesn't have to be so isolated. So you can have it in every city because it simplifies the process. There's not as much cleaning, there's not as much separation, and this way it's much easier for you to increase your recycling rates everywhere.
Fantastic. Thank you very much.
Thank you.
All right, our next finalist is Ella Roberts from the Faculty of Sciences, and her presentation is called Where Do Ghosts Come From? Understanding the Sources of High Energy Neutrinos. Go ahead, Ella.
How would you react if I told you that right now millions of invisible entities are passing through you? Now, there's no need to panic. I'm not talking about spirits or Casper-like ghosts. I'm talking about ghost particles, neutrinos. Neutrinos are a type of elementary particle, and this means they cannot be broken down into smaller parts. The nickname of the ghost particle is particularly well earned, as neutrinos are almost massless, cannot be directly observed, and interact very rarely. This means they truly can just pass through us. Despite their difficulty to observe, we still do get to see them here on Earth, and that's simply because of their abundance. But that begs the question, where are all these ghosts coming from? Well, the boring answer is that a lot of them have low energies and are mostly coming from the decay of elements in the Earth or from the fusion of elements in our Sun. On the other end of the energy spectrum, we reach the high energy neutrinos, and the exciting answer. We aren't exactly sure where they're coming from. Now, it is true that scientists have linked the direction of neutrinos to a blazar in our universe. This is an extremely energetic object that could accelerate neutrinos up to the energies we observe. However, we also see hundreds of single neutrinos all across the sky, and this suggests that there are many weak sources out there. So, at the moment, we can say that the number of neutrino sources in the universe is somewhere between one very strong source and a lot of weak sources. As you can see, this is not a great estimate, and that's why my PhD revolves around narrowing this range down. To do this, I calculate how likely each possible combination of source strength and source number is, and compare them to see which is the best. Now, this is not an easy task. There are trillions of combinations, a multi-dimensional integral to solve, and a calculation time much longer than that of a PhD. But with a method called importance sampling, we can quickly target what makes up the bulk of this likelihood, greatly reducing computation time and making these calculations achievable. Successfully constraining the number of neutrino sources and their strengths will help identify the specific types of objects that are creating them. Is it a universe of blazars just blasting neutrinos at us? Is it just single neutrinos from thousands of gamma ray sources? Or is it a combination of these objects and others? And to what ratio? Regardless of the answer, we'll be a bit closer to discovering the truth about where ghosts come from.
Fantastic, thank you, Ella. Your question from the judges is, how do we detect neutrinos?
Okay, yeah, so I said that we can't directly observe them, but we can see the byproducts they make when they do interact. And we observe this pretty interestingly in very clear mediums, and I focus on our observatory at the South Pole, the Ice Cube Neutrino Observatory, which is actually cubic kilometres of detection space under the ice. We use that medium because that's where we can actually see them interact when they do and create the particle like the muon or electron, which we can actually observe and, yeah, point in the back.
Fantastic, that seems really interesting. Thank you very much, Ella.
Thank you.
All right, our next speaker is Harry Carpenter. He's our second Faculty of Engineering, Computer and Mathematical Sciences finalist, and his presentation is entitled The Silent Pandemic. Take it away, Harry.
We are living through a silent pandemic. And no, I'm not talking about COVID-19. This silent pandemic has been growing for decades and is the single largest cause of death globally. In 2018 alone, it killed over 18 million people. That's more than 4 times COVID to date. Put another way, 106 more people will die from this silent pandemic before I finish speaking to you. Any ideas what it is yet? Maybe cancer, woodworking accidents. My last name is Carpenter, after all. No, it's cardiovascular disease, and the largest contributor are heart attacks. Chances are you know someone who's been in that boat. A friend, a parent. For me, it was my grandfather, roughly 2 years ago. The problem with this pandemic is that doctors do not have a reliable way to predict if someone's cardiovascular disease will progress and cause a heart attack. And that is exactly what my research aims to address. Now, the main troublemaker here is a pesky guy called atherosclerosis, who attacks the heart by causing small fatty particles to build up in our arteries, forming plaque. As these plaques grow, they block our arteries, suffocating our heart of the very life-giving blood it needs to survive. But by using a technique called fluid structure interaction, or FSI for short, my research is simulating how those fatty plaques interact with the blood flow and artery wall, much like the interaction you all might expect to see between, say, my hair and the breeze on a windy day. Now, this is important because the forces produced by this interaction can help keep arteries biologically stable, meaning cells function normally. If abnormal forces are at play, such as very high or very low friction between the blood flow and artery wall, which we call shear stress, then this balance can be thrown out of whack, and pesky atherosclerosis will rear its ugly head. In fact, my research has already suggested that just the way the heart moves and contracts in every heartbeat could significantly impact these forces, altering not just your risk of future plaque growth, but the very area of the arteries it grows in. So with further research and development, the results from these simulations could then be used by doctors to get a clearer understanding of a patient's risk of future heart attack, specifically tailored to them, meaning they can intervene earlier, more accurately, saving lives. Lives such as my grandfather's, lives such as the 106 that we just lost to the silent pandemic.
Thank you very much, Harry. Your question from the judges is, how far away is this research from being employed in the clinic or being studied in clinical trials and validated by clinicians?
Excellent question. In the clinic, I'll start with maybe first. Still, I'd like to say 5 to 10 years as a guess, but we still don't know. In terms of the clinical trials, we're working at the moment with clinical data sets at SAMRI, working with patients who have, say, initial imaging after having a heart attack and then follow up after 12 to 18 months. so that we can get a clear understanding if our simulations are actually getting some kind of predictive power. The challenge with that is then the simulation times with these sort of calculations can be quite long. So what we're really looking for is that 1 or 2% that could make a real difference that we can then target in the, I guess, the real world for patients.
Fantastic. Thank you very much. All right, we're into the second half now with finalist number 6, Jennifer Stokes, who is our second representative from the Faculty of Arts. So her presentation is called Enabling Hope, Building Confidence. Sorry, have we got the order correct? Stoke? Oh, okay, sorry. We'll go with Janine then, yes? I can just click through to the correct slide. Sorry about that, everyone. So we'll go to our finalist, Janine Tam, actually, who with her presentation, Silencing the Alarm of an Inflammation Invasion. And I'll just skip ahead to the... Oh, no, that is you. Sorry, my notes are wrong. My apologies, everyone. Go ahead, Janine.
Behind this wall is a battle against cancer. At the forefront, we have chemotherapy, trying its best to kill the cancer. But like all battles, there is collateral damage, and civilians are dying. In this case, civilians are healthy cells, unintentionally killed by chemotherapy. This causes the most common side effects of treatment, things like diarrhea and vomiting, which not only make people miserable while having treatment, but also reduces their chances of being cured, as chemotherapy often has to be stopped or reduced. But how exactly does this happen? Of all the tissues in our body, the gut has many civilians susceptible to being killed by chemotherapy. But the gut is savvy and has employed its own army to help defend itself, led by none other than TLR4, that sits in the watchtower. Here, TLR4 watches for danger signals from chemotherapy and other invaders, like bacteria, and sounds the alarm for reinforcements against the damage. It's this alarm that calls to action the body's immune system army to eradicate these invaders and heal the collateral damage from chemotherapy. But TLR4 has a tendency to overreact and kills the invaders at the expense of maintaining gut health. So to put simply, in trying to protect ourselves from the damaging effects of chemotherapy, this army actually exacerbates the gut injury. My project is focused on controlling this collateral damage by dampening TLR4's over-the-top alarm response. And how am I doing this? Well, I'll be recruiting the lollipop man over here. He is an inhibitor sent to silence the TLR4 alarm. With this gone, there won't be any reinforcements from the immune system army, which would significantly reduce the amount of healthy gut damage. Then chemotherapy would kill the cancer without causing any collateral damage, which reduces the side effects of chemotherapy, and ultimately improve the quality of life of people with cancer during treatment.
Thank you very much, Janine. Your question from the judges are, what are the challenges in producing that lollipop man, and what sort of techniques are you using to do this?
So I'm not actually producing any of the treatments. They've sort of been produced pharmacologically, and we're just sort of taking them and testing them and seeing which one's the best.
Fantastic. Thank you very much.
Thank you.
Okay, now, sorry about that, Jennifer. Our next speaker is Jennifer Stokes, who is from the Faculty of Arts, and her presentation is called Enabling Hope, Building Confidence, Capabilities and Knowledge Through University Pathway Programs. Take it away, Jennifer.
What brings you to university? What's your hope? Tonight, you're probably hoping to hear some good presentations, some world-changing research that could shape brighter futures. And that's what education does, doesn't it? It offers hope. The promise of a degree is the promise of a better life, knowledge, earnings, a fulfilling career. And many countries around the world are widening university participation in hopeful preparation for uncertain futures. However, people from First Nations, low-income and refugee backgrounds are consistently underrepresented at university. Here, enabling programs offer hope, a second chance pathway for people from disadvantaged backgrounds to earn a place at university. Over 12,000 people take enabling programs in Australia every year. And these pathways change lives. Students who complete enabling programs earn equal or higher grades as their peers in their degrees. However, we still don't really understand how best to support these new students coming to the university. So that's what my PhD focuses on. In my PhD, I've established enabling pedagogy, essentially how best to teach new students and support them into university. Only 50% of enabling program students complete. Why? My research shows it's rarely intellect or commitment to study that lead to these outcomes. It's more to do with complex life pressures and challenges. On arriving at university, a student who's spent years in a refugee camp and is a humanitarian visa holder has different needs to someone who left school in year 10 to work in a factory or have a baby. Yet they often sit together in enabling classrooms and they share a common goal to work hard and succeed at degrees and contribute more broadly to society. So through interviews with students, academics and graduates, I've established best practice strategies to support these new students. Firstly, we need to be aware that many of them have had really negative previous educational experiences, so trust has to be rebuilt through dialogue. Educators who better understand these new students can help support individual needs and design meaningful learning, which supports students to build confidence and capability. Secondly, the needs of the student and the university need to be balanced. Students will flourish as they develop academic literacies and broader knowledges within the university, and the university is bolstered by the new knowledges that these students bring in, like cultural knowledge and resilience. Thirdly, and through this, a transformation occurs. The student builds a positive learner identity. The student and educator learn together through a shared journey, and this works to strengthen universities and broader society. Lessons learned in Australian enabling programs can help shape the widening participation agenda worldwide. My educational hope is that this research helps individuals achieve their dreams and their potential. Thank you.
Just get you to wait so you can answer your question, sorry. All right, so your question from the judges is, can you give us some more examples of the students' backgrounds who are taking up the opportunity of enabling studies?
Yeah, sure. So it's students who in the 1990 Dawkins Review of Education started to be identified as students from equity groups. So the idea is to achieve representation at the same level as population representation. So students from low socioeconomic status backgrounds, students from Aboriginal and Torres Strait Islander backgrounds, students with a disability, students from rural and regional areas, first in family students, humanitarian visa holders, and students for whom English is an additional language.
Fantastic, thank you very much. So representing our Faculty of Professions is our 8th finalist, Sarah Kanti, with her presentation, It Is What It Is, Women's Participation in Agricultural Decision Making. Go ahead, Sarah.
Thank you. What comes to your mind when you hear the words decision making and woman? The suffragettes, jugular, or probably Destiny's Child song, Who Runs the World? How about decision making, women, and agriculture? As an Indonesian, I think about this picture. Major contribution, but less empowered and undervalued. Women comprise about 43% of agricultural labor force globally. Despite the importance of women in agriculture, there are beliefs prescribing social roles of men and women in the society, or so we call social norms, that dictate that agriculture is a man's thing, whereas women only prescribe only as their helpers. Thus, women are expected to have less say in agriculture decisions. Such social norms affects people's perceptions about themselves and others, and also directly affects individual choices, freedoms, and capabilities. For my research, I investigated the roles of social norms in determining women's participation in agriculture decision-making as a way to empower women. I identified to what extent women participate in 21 agriculture activities at the household level and why that the decisions are made that way. I interviewed 439 couples in West Java, Indonesia. I asked husband and wife individually, and I used novel scale to measure how men and women think about women's participation in agriculture decisions. I found that, first, both men and women think that women's participation in agriculture decision is less than equal. Second, speaking of the decision-making processes, women tend to respond that the decision is made like it is what it is. That is how the decisions are made in their family or village. Whereas men tend to respond by saying that the decisions are made according to whoever has better knowledge about the activity. These findings suggest that women could have higher participation in agriculture decision in the household level if it is common in the community. Thus, this information can be used by the government or NGOs to design a better gender-inclusive interventions in the national or community level. Thank you.
We'll just get you to wait so we can ask you a question. Thank you. Thank you. So your question from the judges is, this new knowledge and understanding of the existence of these social norms is fantastic progress, but how do you anticipate your research will change this? So what exactly do you think the government and the NGOs will be able to do to change these situations?
Okay, thank you for the questions. So up to now, based on the literature or common knowledge, like social norms is there. However, very less like scientific results that that prove that it is really affecting the woman participation in decision making. So by my research, like proving this, and I really hope that government and or NGOs or the policymakers can really see this, like a proof, scientific proof that they can use that for their interventions.
That's great. Thank you very much. Right, our next speaker is Tassia Oswald from the Faculty of Health and Medical Sciences, and her presentation is entitled Green Views for Screen Blues. Take it away, Tassia.
COVID-19 has changed life as we know it, and mental health consequences may be one of the greatest impacts of the pandemic. However, research tells us that depression and anxiety were already on the rise among young people before the pandemic began. Experiences of mental illness in adolescence are linked with poorer mental health across the lifespan. So we really need to prevent mental illness before it develops in young people, rather than just treat it once it presents. So what has caused this rise in youth mental health problems, and how can we help prevent it? Screen time is a unique feature of contemporary adolescence, which is regularly argued to be linked to the rise in mental illness. Young people report spending an average of 7 hours per day in front of a screen. And alongside these increases in screen time, young people's time spent out in nature, or green time, has also decreased. Young people report an average weekly green time of 6 hours. This is less than their daily screen time. But what evidence is there that these two trends actually impact on mental health? Well, in my PhD, we brought together evidence from almost 200 international studies. We found that high levels of screen time were typically linked with poorer mental health, while green time was typically linked with better mental health. But why might this be? Well, from an evolutionary perspective, we evolved to function best in natural environments over millions of years. But this extensive evolutionary tuning is lacking for tech environments. When in nature, our brains use something called bottom-up processing. This means we're using the most ancient parts of our brain at the bottom. This is quite relaxing. It can boost our mood and restore our attention. But on the other hand, during screen time, our brains use top-down processing. This means we're using newer parts of our brain around the top. This is actually quite demanding. It can fatigue attention and make it harder for us to manage our emotions. So, given screen time and green time affect mental health in such contrasting ways, I asked, could we use green time to help buffer the psychological consequences of screen time? And that's what the final phase of my PhD is looking at. We've been getting young people to complete measures of mood and attention, first at baseline, then after screen time, and finally after a period of rest, either in an indoor setting or outside in the Botanic Gardens. We anticipate that mood and attention will decrease after screen time due to that demanding top-down brain processing. But after the rest period, they'll be restored. However, we hypothesise that mood and attention restoration will be greatest for those in the Botanic Gardens due to that relaxing, bottom-up brain processing when in nature. If our hypotheses turn out to be true, nature immersion could be a great way for young people to support their mental health in an unavoidably high-tech era. Green views could be the perfect antidote for screen blues.
Awesome, thank you very much, Tassia. So the question from the judges is, if that hypothesis is correct, do you have any ideas on how to make that green time more attractive to young people so that they choose it over screen time?
Yeah, sure. So in my research, we broke down our analyses by different age groups. So my main focus has then proceeded to be on adolescents. So that kind of 13 to 15 age range has been our target. And we found that young people, their contact with nature is more incidental in that age range. So that means instead of always getting out there and being active and sporty, going to a park and running around on the grass, they prefer to be in kind of high quality natural environments. So just being in nature may help them buffer that screen time effect. So a way we could do this without having to make it attractive to them, having to convince them to go and do it, is to green our schools, to green our communities, and to really think about implications of high density housing if we don't have yards, backyards for young people to be exposed to that green time.
Absolutely. Thank you very much.
Thank you.
All right, and lucky last for the evening is Trang Nguyen from the Faculty of Professions. Her presentation is very topical. Help that banana peel rot in the right place, the green bin. Take it away, Trang.
Think back to the last time you ate something. For me, it was a banana. After repairing or eating your food, you may have been left with some food scraps. Me, I was left holding a banana peel. In this situation, the question is not to dispose or not to dispose, but rather where to dispose. I'm going to talk to you about our food waste. When in the compost, a banana peel takes about 4 weeks to fully break down. What if it ends up in landfill? You might think it would take a similar amount of time, but it can actually take over 50 years. What? Why so long, you may wonder? Yes, organic material cannot break down in landfill because there is not enough oxygen for composting to take place. Worse, the lack of oxygen creates methane, which is 28 times more potent than carbon dioxide, contributing to climate change. In South Australia, food waste is allowed in the green bin, and from that would get composted. Yet, in most houses, about half of the general waste bin is food waste. So, why does so much household food waste go to landfill, causing enormous environmental impact? I conducted focus group and surveyed over 1,000 Adelaide residents to understand the attitudes and behaviors around food waste. My results show while 82% of Adelaideans agree that putting food waste into the green bin is the right thing to do, only half said it is important for them to sort and separate food waste from their general waste. Less than half of our research participants dispose their food waste properly by putting it into the green bin, composting it, or feeding it to animals. My research is also looking at what types of attitudes and demographic characteristics help determine food waste practices. The results will help government and industry better understand household attitudes and practices, enabling them to design better programs or incentives to reduce the amount of food waste that is generated and the amount that ends up in landfill. In the 3 minutes that I've been speaking, more than 13 tons of food waste has been sent to landfill by Australian households. So collectively, if we, reduce our food waste or divert it from landfill, we can have a positive environmental impact. So, if you have banana peels like me today, have it rot in the right place, get into the green bin. Thank you.
Thank you very much, Trang. So your question from the judges is, based on the progress that you've made so far, do you think that households aren't attentive, so they don't care about the daily waste decisions, or are they not aware of what the right decision is?
I have just had a very preliminary analysis. However, it's a mix of things. So some of the participants or our participants are not aware that food waste can be put into the green bin, and some of them are do not have the capacity to do that because they are living in a unit or an apartment that they do not have access to the green bin. But I think there's also part of our because we found that people have the higher concern for their health. They have a higher scale for health consciousness. They're less likely to sort food waste correctly. So I could say it's a mix of lack of awareness, lack of capability, and also do not really care about sorting food waste into the green bin.
Absolutely. Thank you very much. And thank you to all of our finalists for their presentations tonight and their video submissions before this and all of their ongoing research. So prior to tonight, the judges have viewed the video submissions and made their final decision, which I will announce very shortly. But before that, we all get to vote, and we want to hear from everyone here and online for the People's Choice Award. So depending on what platform you're viewing this session on, if you're in the lecture theatre, you will have a QR code up on the screen, or depending on whether you're on Zoom or on Facebook, there'll be a QR code that you'll be able to have a look at. So, oh yeah, sorry. Forgot about this part, that's on me. To remind you of who all of our presenters were, because it has been 30 minutes, I'm going to ask all the finalists to come back up onto the stage. Leave your masks on, I think, if we're all together. Yes, that makes sense. And I'll just run through who all of our presenters were again so you remember and you're familiar with their names. So our first presenter was Alana Delane with This is the House That Wasps Built. Our second finalist was Caitlin Adams, Spotting the Difference in Online Video. Probably just give a wave, I think, something like that. Our third speaker was Chai Yi Liao with Plastic Recycling Reimagined. Our fourth finalist was Ella Roberts, talking about where ghosts come from and understanding the sources of high-energy neutrinos. Next was Harry Carpenter, speaking about the silent pandemic. And then we had Janine Tam, who was talking about silencing the alarm of the inflammation invasion. Next was Jennifer Stokes, who was talking about enabling hope, building confidence, capabilities and knowledge through university pathway programs. Next was Sarah Kanti, talking about It Is What It Is, women's participation in agricultural decision making. Next was Tassia Oswald, who was speaking about green views for screen blues. And then we had Trang Yuan, who was talking about helping the banana peels rot in the right place, the green bin. So these are all our fantastic finalists, so you know who they all are now. These guys can go and take a seat, and then we'll get on to the People's Choice judging. All right, so this is our QR code. So if everyone could grab their phones out, we're going to give you probably 3 to 5 minutes to cast your vote. There may also be a poll that's come up on your screen, depending on the platform that you're watching on. Able to go to Slido and place your vote as just sort of follow through the prompts and that sort of thing. So like our judges who have viewed the video submissions, we want you to base your decision on those two categories, comprehension and content, and engagement and communication. That's right, so we're going to give you a few minutes to vote, and I'll be back in, let's say, 5 minutes. All right. Go. We now have a People's Choice winner, so that's fantastic. Thank you very much to everybody who voted. Before announcing the category winners, I would like just to congratulate all of our finalists for such a fantastic effort, especially in the unusual and trying circumstances that we're coping with. I know it's not easy to, film a video and then also have to present live, so you've all done an incredible job. All right, so we're going to start with the Students' Choice Award, selected by the students from USC, Pulteney, Adelaide High School, St. Peter's and Eynesbury. All right, so I'm just going to go here. So I'll ask the student representatives to just come up, and we've got, so the student's choice is a $250 voucher, but we're going to just use a bottle of wine to signify this. So here you go, boys. So you guys hang on to it, and then you can present it to the winner when they come up. So maybe just come up to the front here, and that's sort of prime spot for photos. So the winner of the Students' Choice Award is Tassia Oswald. And we'll do a photo just at the front there. Are we good? We've got. All right, thank you very much. All right, now for the People's Choice Award, which we all just voted on, and I get to present this one. There you go. So the winner of the People's Choice Award gets a $1,000 travel voucher, and we voted on that, obviously. And tonight's winner is Tassia Oswald. All right. Okay. Finally, on to the overall winner of the 3-minute thesis for the University of Adelaide competition in 2021. As voted by our panel of judges based on the video submissions, the winner is Chang Yuan. Congratulations, thank you. So you can leave that with, in the back, yep, sorry. So you can leave that with me. All right, fantastic, thank you very much. All right, so that is it. We've come to the end of another 3-minute thesis competition at the University of Adelaide. Congratulations once again, not just to the winners, but also to everybody who's participated in the final tonight. Everyone who participated in the heats, who had an idea and made a video at all. It's a fantastic experience and you should all be very proud. All of your presentations tonight provided a fantastic insight into the work that we do as a university in order to further our understanding of the world around us. So thank you all very much again for being a part of tonight's event. So for the rest of you, don't forget Research Tuesday starts again next month. So please check the Research Tuesday's website for more information. Thank you all very much for coming and good night.